Hi Year 5, welcome back. A new half term leads us to a new science topic, all about reversible and irreversible changes. And our objective today is to be able to understand the differences between reversible and irreversible changes. Now, first of all, I want you to think about those two words and what they actually mean. What does it mean if something is reversible? I wonder if you can think about something which you might be able to kind of put that into context with. If something's reversible, it means you can change it back to how it was. And if something is irreversible, it means you can't. So have a look at my pictures here. Some things have been changed here reversibly, so the change can go back, whereas other things here are changed irreversibly. It's something which can't go back. So I've got this picture here is representing bread being made to toast. This one here is ingredients in a cake batter being turned into a cake. This one here is logs being burnt on a fire. Got a candle melting. You've got some salt or sugar being put into some water so it can dissolve. Here you've got some dough that's been baked into some bread. You've got some ice melting into water. And finally then you've got an egg being cooked. So which is reversible and which is irreversible? Pause the video and have a little bit of a decide for yourself. Okay, welcome back. So I wonder what your final decisions were. Let's have a look at them. So the bread, as soon as a piece of bread has gone into a toaster, you can see it's really changed. It's gone much more solid and it looks different. It's changed colour. And actually, this change can't be reversed. You can't get a piece of toast back to being a piece of bread. I know people in class say to me, oh, but if you make a piece of toast quite sort of wet and put some water on it, it kind of goes back to being a bit like what it was before. But maybe if mum or dad say it's okay, you can give it a try and you'll see you never quite get the same piece of bread back. It has been changed irreversibly. Moving on to the cake, hopefully you recognise this is an irreversible change. Once this cake here has been cooked, there's no way to go back to this batter that it was once before. When you burn something, again, it's gone after that. So again, it's irreversible. I can't burn something and then expect to get back what I had before. Once these logs have been burnt, there's no way of getting them back again. It is an irreversible change. Melting a candle, this one's irreversible as well. I promise there are a couple of reversible changes in here, but many of them are irreversible. If you think again, once a candle has been burnt, you can see then that you can't rebuild the candle, you can't get it back. What about down here then, the egg? If you think about when an egg is put onto a frying pan and is cooked, it changes from looking sort of all see-through like this to going sort of more solid and white like this. And again, it's irreversible. I can't take the egg back. I can't get the egg back to being this kind of clear thing that it was before once it's been cooked. I wonder if you're noticing any kind of similarities so far between these ones we've looked at. So I've cooked this one, I've cooked this one, I've burnt this one. This is about burning as well. This is about cooking again. Lots of things here about heat, and that's quite important with irreversible changes. This one here though, the ice melting into water, this is the first reversible change here on the board. When ice melts into water, you can freeze the water again to turn it back into ice. Okay, you might not get it looking quite the same again, but with the right molds, you certainly could. So this makes it a reversible change because you can go back again to the state that it was before. Okay, the state has changed, but it hasn't been changed irreversibly. Dough going into bread. Again, this is another irreversible change. A little bit like even that bread then changing into toast. Actually, the first stage of the dough being changed into bread, okay, you can't get that back. And the same with actually making the dough in the first place from these ingredients you can see here on the side. Once they're here and they're mixed within this dough, you can't get back to these original ingredients again. Finally then, putting the salt into the water. I hope you remember doing this. Before we went into lockdown, we did an experiment and we had all sorts of different things. And we had, remember, there was rice, paper clips, there was some salt, and there was some sand. And you had to separate that mixture of all different things. And at the very end, you were left with salt water because we used water to try and separate some of the other some of the, I want to say ingredients, but some of the different substances from one another. And actually, we said at the end, although we didn't actually get our salt back, if we'd heated the water, we could have evaporated the water and we could have then been left with some salt. And we did leave some on our windowsill just to see what happened. So this one is a reversible change because once the salt's gone in, it's been stirred up and it's dissolved, I can still then heat the water, evaporate the water away, and be left with salt. So there are some of the different reversible and irreversible changes. You might even be able to think of some more yourself. So thinking about those things then, I wonder how you would define a reversible change and an irreversible change. Have a go now. I've put a couple of pictures to be able to help you, or you might even want to just go back a little bit on the video just to see these pictures again for a little bit longer. But how can we define what makes a change reversible and what makes it irreversible? Pause the video, have a go at writing your own explanation just from what we've talked about so far. Okay, welcome back. I hope you got on well. That will show you what I have written here. So for my reversible change, I've said this is something which is called a physical change. You probably haven't got those words yet, but you can always add them into your definition now. So it's a physical change. This is when the materials may mix together or appear in a different state, but their chemical properties have not changed. We talked about that a moment ago a little bit with the ice. The state has changed from being ice to being water. Then the idea of materials mixing, the water and the salt in the cup. But actually the chemical properties, the actual physical properties of the objects has not changed, and therefore it can be reversed, it can be taken back. And then an irreversible change, I wonder if you can up-level yours again now. This is a chemical change. This is when a new substance is actually formed, and they're often quite visible. You might see bubbles, you might see colour changes, you might see temperature changes, a flame, or even an explosion. These often occur through cooking and burning and rusting. And we talked a lot about cooking and burning with all those changes we saw at the beginning. Cooking things actually changes their chemical structure, and that's why lots of those changes are irreversible. So I'd like you to watch this little clip now, just to see just a little bit more about irreversible changes.
Perfect. Another chemical reaction has just happened here.
Chemical reactions are useful in cooking. They help improve the taste of food. Cooking and chemistry have quite a bit in common. The starting materials in a chemical reaction are called the reactants. These react with each other to form a completely new substance, the product.
As you can see, products have very different properties to the reactants. This cake is a lot firmer, tastes a lot nicer than the individual reactants. It's a different colour too.
Not all chemical reactions need heat energy to make them happen. Take some bicarbonate of soda, add a little vinegar, and watch. It's another chemical reaction. This time one of the products is a gas, enough to inflate the balloon.
I hope you enjoyed the clip. In that clip we saw eggs being cooked. I want you to think about how the eggs actually changed. So you see that the eggshell is cracked and the raw egg pours into the pan. As liquid egg white and yolk are heated, they start to change. The clear liquid egg white firms up and becomes opaque white. Do you remember opaque? It means you can't see through it. It changes into a solid. and the orange liquid egg yolk also solidifies and it turns lighter in colour. So those are some of the changes in that irreversible change. Heat causes irreversible chemical changes to occur. The cooked egg cannot be cooled and it cannot be turned back into a raw egg, no matter how hard you try. It's a chemical change because a new product has actually been made, and irreversible because it cannot be changed back. In comparison then, here are some things here which are reversible changes: melting, freezing, evaporating, condensing. Okay, you can see here the steam coming out of the kettle, and it's touching onto this surface, which would be quite cold and be helping it to condense, and the water dripping down over here. And then here's some sugar about to be dissolved in some tea. These are all examples of reversible physical changes. These are physical changes rather than chemical changes because no new materials are created, and they're reversible because they can be changed back or reversed. So have a look here at my own explanation about my irreversible change of the egg. So I've said when an egg is fried, it's an irreversible change because the heat causes the egg's chemical structure to change. Once it's been heated, it looks different. It is white and no longer clear, and it is solid rather than liquid. There's no way to get the raw egg back from this new product. And it's important to remember that heat caused the chemical change to occur. You heard lots of words in the video like reactant and product. And the reactants are the materials that you start off with before the chemical change happens, while the products are the materials that are formed in the chemical change. So you need to think just a little bit carefully then about what the reactant and what the product was in the egg example. And what actually caused that chemical change? Well, we know that it was the heat that caused that chemical change. Your job now then, I'd like you to have a go at making a little table like this one below, or you can print the one from the Google Drive if you'd like to. And then there are some pictures of some different changes, and I want you to make a decision if they're reversible changes or irreversible changes. Here's what the pictures look like, and again you can get this from the Google Drive. So you've got melting chocolate, toasting bread, candle burning, wax melting, and many, many more. So I'd like you to have a little bit of a look. You can either print these off and organise them into your table, or again, you might just want to write the words into the table yourself. Once you have had a go at organise them into the table, you need to then decide on one reversible and one irreversible change and write a sentence or two to explain what changes have occurred and why this makes them reversible or irreversible. Over the course of this half term, we're going to be taking part in lots of different irreversible changes. We've looked at some reversible ones previously, and this time we're going to be trying to see what different reactions we can create and what different products we can make by looking at some irreversible changes. We look forward to exploring these with you. Speak to you soon. Bye.